Hello, everyone. Good morning, good afternoon, good evening, and welcome to the Washington Labs Academy webinar series. We hope you find the next hour so useful and informative. We've developed our webinar series to deal with some of the technical and administrative issues that our customers face on a day-to-day basis. And we recognize that engineering challenges can be complex, and we're always looking for ways to support the technology industry. A couple of quick program notes before we begin the webinar. We estimate the main bulk of this presentation will be about an hour. You're welcome to submit your questions to the host via chat, which we will go over after the presentation. And you can always submit your questions via email. Please note that a recording of this presentation will be sent to all attendees. And now I'd like to go ahead and introduce our presenter. Corey has 15 plus years experience in environmental and safety testing, ranging from computer keyboards to critical components on the International Space Station, primarily focusing on vibration testing for military and spaceflight equipment. He is also often engaged in evaluating ruggedized COTS devices to the climatic and dynamics requirements of MIL-STD 810, DO-160, and a number of other industry-specific test standards. So let's turn our attention to Corey and his presentation covering MIL-STD 810 DO-160 for military and aerospace devices and systems. Hi, Corey. Go ahead. Take it away. It's all yours.
All right. Let's see if we can sort this out. All right, so I think we are good to go. So good afternoon, everybody. Apologies for any hiccups during this. I'm normally sitting next to a vibe tape rather than in a room full of people talking. So little different, little interesting, but we'll see how everything goes. So today we're pretty much going to be going over 810 and DO-160 for general military and aerospace stuff. Get straight into it. So kind of starting on where the standards came from. So post World War II, the Army Air Force, before the U.S. Air Force was actually created, made this AEF specification 41065 to kind of create a baseline for testing environments and testing procedures. The MIL-STD didn't actually really start until 1962 when it was created, and it was really basic. I mean, I don't know if anybody's ever gone back and looked at 810B or 810C, but there's not a whole lot to it. Once it got to Rev D in the early 80s, which really started coinciding with a lot of the military progress, the Abrams program, stuff like that, they really started to expand the standard, added a lot of stuff for tailoring, that sort of thing. And it hasn't been exactly 10 years for every release, but it's been roughly that. DO-160 or RTCA, so the Radio Technical Commission for Aeronautics, which nobody ever says, is sort of similar to 810. The original one, DO-138, was published in the late 60s, kind of turned into something in the mid 70s. And it is similar to 810 in that it's a test standard, but it primarily focuses on aircraft equipment and components, ultralight stuff, rotor winger helicopters, Supermax, all the big guys. So for flavor picture on this slide, if you've never heard an A10 go Bert, it is something that is very interesting to hear. If you can arrange it at a live fire air show, it is extremely neat to see the equivalent of a tank flying over at about 100 feet. Doing some really interesting things. So to get past the origin, so kind of why do you use these standards? 810, originally intended for military stuff, it is expanded to cover almost anything you can think of: cell phone cases, cell phones, external hard drives, avionics equipment, tank components, pretty much anything and everything can kind of get slotted into 810. And the testing be relevant in some way. Yeah, DO-160, kind of the same thing. Mostly for commercial. It does occasionally get called out for military stuff or hybrid roles. U.S. Border Patrol uses DO-160 and A-10 to qualify some of the equipment in their light aircraft, like Beechcraft and stuff like that, I think. The DO-160 is a less universal standard, and that allows it to focus in more on requirements for airborne equipment than 810. But that does also mean it's not as useful for other things. You're not going to use this for Pelican case. It's going to go in the back of a Humvee, as an example. Mostly for commercial aircraft, really. When it gets into tailoring for the tests, 810 essentially requires it. So, and this is straight out of 810, where it says it goes as far as to say that simply calling out either individual or multiple tests in a blanket fashion isn't correct. You can't just say we need to test to 810, 810G being the most current one. It's just not a good approach, because there are a lot of tests that aren't going to be applicable to a lot of things. But in having a blanket approach like that, you're also ignoring a lot of the tailoring, a lot of the customization that needs to be done to these procedures to really make 810 work for, the project you're on. There are, significant is an understatement in the amount of information, guidance, and annexes that MIL standard has as far as explaining why things happen. It's kind of like the interpretation standards IEC puts out to explain why the standards say what they do without having to say it in the standard, but MIL standard just puts everything into the standard. One of the nice things about it is that, as far as I know, all the MIL standards are free. So even if you're not using it right now, you can download it, you can read all kinds of stuff. There's an absolutely insane amount of information on vibration levels, temperature levels, how to get to what you need to test. So if you're a PM and you're looking at, okay, what test do we need to do, and you don't know, 810 has a lot of guidance criteria to tell you kind of, okay, what test do we need to do? How do we get these levels? Where do these levels come from? That sort of thing. There's a lot to the guts of 810 that we're going to skip over. This is, each procedure in 810 could honestly be its own week of training. We're going to try to squish everything into a little less than an hour here. DO-160 doesn't have nearly the amount of tailoring. DO-160 is a lot more of a set meal approach than kind of the buffet approach of DO-810, in that a lot of the levels and parameters and stuff listed in DO-160 are what you test to. It's a lot more similar to, say, an EMC standard, where you have hard criteria, not so much in pass and fail, but hard criteria in, as far as your test levels, test specifics, and that sort of thing. So some other considerations on these two standards. So we're focusing just on 810 and DO-160, but there are a lot of other standards out there that are used. So most of the time when one of these two are called out, it's a procurement agency requirement. It's a checkbox for somebody on a list. It's a program requirement, just because of the general use of the standard. Sometimes we'll have an older version called out. So MIL standard 810G is the most current version now, but I've seen stuff go all the way back to MIL standard 810D. Quite often that's because if the military especially is looking for a replacement part, an in situ replacement part, most of the time the procurement requirements are that the new part be tested in a very similar manner to the original part. So you may have something that's made in 2024, but they call out Rev E of the standard, which may have been early 80s. So there are some jumps in standard revisions when they're used. Most of the time, the procedure is relatively similar. The levels do change a good bit, and you get a lot more tailoring and guidance in the newer versions.
When you go to the next slide, you have to change your slides because they're not showing it.
Okay. So there are a lot of other standards that go along with 810, 202, 167, 648. We're not really going to get into those, but it is worth taking into account that there are some other standards that might be called out, that might be required for the program you're on or for the testing you need to do. 810 may not have the most applicable test or levels, and you may want to look at a different standard. DO-160, it's a lot less common with those projects because typically with DO-160 requirements, they're set, and there's, again, with a lot less tailoring, you're calling out requirements directly from DO-160, and it tends to be kind of a mono standard requirement. So we're going to get straight into the tests because this is where all the fun stuff starts. So these are kind of ranked in terms of not most important to least important, but most common to least common in terms of military equipment and avionics equipment that is going to go through this type of testing. So temperature kind of combines here a couple of different ones. MIL standard 810 calls out multiple methods for these tests. So the operational test, the non-operational test, these, well, the high temp and low temp are both different methods. DO-160 kind of covers everything in one big chunk. So the four main types here are kind of your operational. Operational in MIL standard is just operational. In DO-160, you have a regular operational, what they call a short term. There's kind of a storage or non-operational. Standby to operational, which is kind of a tactical standby. It is a relatively new addition to 810. And manipulation, which is a low temp only, and that mostly looks at how well equipment can be manipulated while wearing cold weather gear, gloves and that sort of thing. And that is, at least for what I think most people watching this are going to be testing, relatively uncommon. Picking your levels and all that good stuff. 810 has a lot of information again on different climactic zones across the world. They have minimum, maximum levels. They have diurnal cycles to use. And you can either go with the requirements, say A1 basic hot out of 810, or you can kind of look at, okay, what's the general geographic area we expect the stuff to be deployed in, and use those levels to springboard into something that's a little more effective, a little more useful. You can also just completely ignore the levels in the standard and do whatever you want, and just use the procedure as a baseline for the procedure, and do a test at 150 degrees Celsius if you don't think 50 degrees Celsius is enough. Most of the time, the durations here go from, for operational high temp, it can go up to 7 days. Normally, it's shorter than that. Normally, 3 days is common. 24 hours is common. Low temp for operational storage really go from 20 to 24 or 2 to 24 hours. A lot of that is because you're going to see more degradation from high temperatures and low temperatures compared to cold, where stuff kind of stabilizes at low temp and it just sits there. DO-160 is a lot more rigid in the requirements. You kind of get options, and these are really based on where the equipment is installed on the aircraft rather than where the aircraft is going to be. And then with DO-160, with 810, there's a lot of variation in the procedure. You can kind of really do it however you want. You can follow the procedure, but with DO-160, you kind of have to follow. They have a step-by-step structure on how the temperature test is performed. So you start at, say, your low temp storage, then you go to low temp short-term operation, low temp full operation, and there's an entire procedure with that you really do need to follow with DO-160 most of the time, unless the program gives you leeway to not. Just one of the differences between the two standards. For the fun picture here, so this is about the most damaged I've ever seen a Pelican case. They're pretty much indestructible. I think the only thing we've ever done is broken off a small flange on a quarter of one, but somebody set the toaster a little bit too high on this guy and melted it just a touch, which it probably still functions fine as a Pelican case, which is kind of amazing, really. So the next one is humidity, so relative humidity. And for this standard, it mostly refers to high humidity, not low humidity. Low humidity is more of a problem for safety standards and that sort of thing, where you're looking at unexpected ESD discharge, that sort of thing. For this climactic stuff, we're looking at high humidity most of the time with high temperature, although there are a few occasional low temperature, high humidity tests called out. Two basic types, operational, non-operational, and really most of the time it's a hybrid of the two. So 810 goes back to those same climactic zones as the temperature stuff. They give you different levels. Again, a lot of information, a lot of historic information in the standard on where the numbers that they have, where those come from. Two basic types of tests, natural and induced, which are the very long-term tests. So these are more realistic profiles that have been logged somewhere, say in Panama. They have a number of days that they've actually logged data and they come up with this profile. The thing with these tests are the natural and induced really go from 15 to 90 plus days, and they're extremely long. They're relatively uncommon because of that. The aggravated profile, which is procedure 2 for 810, it's a 10-day test with a mandatory preconditioning test at the beginning. It's the most common, really, because it's the shortest in the standard. It's probably going to be more severe than real conditions are going to be in the field. Sits at 60 C at 95% for a good period of this 10-day cyclic test. But it does still wind up being the most common. DO-160 is kind of as it's been, a little more limited. There's 3 major categories: standard, severe, and external. Standard is, I believe, 2 days. Severe is 6, and external is 10, although I may be wrong on that. No, don't have DO-160 up to look at. Severe is the most similar to the aggravated. Standard is really kind of what you would expect to see in any normal place. There's nothing too crazy about that. External is also very similar, but it takes into account that the equipment's going to be on the outside of the aircraft or stored externally, and the levels are a little bit higher. But DO-160 doesn't have anything like the long 90-day cycles that 810 can call out sometimes. 810 does allow the requirements to be tailored some, although this is relatively uncommon. To say the most common thing is chopping the profile in half to 5 days when either something absolutely has to be finished early or somebody has justified a shorter test duration. I'd say most of the things that fail during 810 humidity fail early, but there are occasional things that fail later in the cycle. 810 calls out as a basis operational test at the end of the 5th and the 10th cycle. Now, you can operate it for the duration. You can operate it not at all. You can operate it more frequently, less frequently. One thing to think with the operational test, though, is that you're not going to know your unit's failed until you run an operational check. So if you do a 10-day test and the unit actually failed on the 1st, you've just lost 9 days of testing on a failed unit that you didn't know about. So there's some reasons to do operational a little bit more frequently, but that's the general requirement. DO-160, kind of a light version of 810 again. It's really not going to be operational for the duration of the test, but it does have a requirement that within an hour of coming out, without being wiped off, that the EUT is operated to see what happens. Typically, the same thing happens with 810, but DO-160 again is just a little light version on this. And flavor picture, fogged up displays. More common in the summer when you get out of a very nice cold car with the AC blasting and it winds up being 8,000,000% relative humidity outside and things fog up. But this is one of the things this test looks for. Is not just electrical failures, which is pretty common with water infiltration, but screens fogging, materials deteriorating, that sort of thing, because of the effects of humidity. Not just the humidity, but the temperature with it, because those are normally combined. Next, vibe. And so this is split up, one screen each, vibe for 810 and for DO-160. And vibration testing honestly could be its own entire month's worth of talk. There is a lot of stuff that goes into vibration testing, picking profiles and all that fun thing. So procedure types, again, this is pretty recurrent. You've got an operational, and you've also got a non-operational and or package. Those are typically separate. There are tests where people want to run the entire vibe profile with it non-operational, and there are some that will run the same profile with the equipment package. It really just depends on what the program calls out, what the equipment's going to see. DO-810, there are 24 categories, mostly divided between ground, aircraft, which is split between prop, turboprop, jet, and rotary. And there's a little bit for shipboard stuff, although not quite as much because there's some separate standards that go into more detail for shipboard equipment. It's a very different environment than most of the other stuff for these vibe profiles. You can kind of chunk it down into large and small things, operational, non-operational tests, and packaged and unpackaged for 810. Depending on what you're testing, depending on where it's going, you've got sign, random, sign on random, and random on random. Sign being kind of the most basic and really least common that I can think of for 810. Random is the basic. That is kind of the, you know, McDonald's Big Mac vibe test. That's what everybody thinks of most of the time for vibe testing. Sign on random is for some things like aircraft where you've got a constant vibration, say a turbine, but you've also got random. So a helicopter flying through turbulence would be kind of an example of that, where you've got your constant turbine noise creating your sign profile, and that's superimposed normally in narrowband spikes, but not always, on a broadband random profile. Random on random would be more similar to something like a tank, where you've got tread pitch noise, you've got engine noise, you've got just the vibration itself of the tank transversing terrain. And those are really going to be dependent, those profile types are going to be dependent on what the equipment is installed in almost all of the time. There may be some other references. MIL standard 167, the newest version is 1A, I think, is the shipboard test. There's a procedure, a method in 810 that is essentially the exact same thing, and it's one of the 526 maybe. This is a very limited test, but it is a lot longer in duration. It's about 3 days. ITOP requirements are for a lot of the more complex sign on random and random on random tests. And sometimes you have to reference external standards to find the requirements you really need, the profiles you really need for testing. There are some durations. Most of the time it's 1 to 4 hours per axis. Sometimes it will go longer, sometimes it will go shorter. Sometimes the durations are dependent on, for some of the aircraft, they give you X minutes equals so many landing and takeoff cycles. And so a lot of this goes back to, you know, kind of if you have a test plan or tailoring, where you've identified what these durations are. 810 lists them as basis, but that's really all they are. It's kind of the foundation that you're putting the rest of the stuff on to make the test really valid for what your equipment is. It is, yeah, pretty much it. Tailoring is most essential for a successful test program and equipment use and survival during field use. Most of the other tests in these standards are not going to be as critical as vibe is in finding stuff that fails. Field data is typically a good thing, although most of the time people don't have that, so profiles can get mashed up. You may take 2 different land-based profiles and use the low frequency stuff from one and the high frequency stuff from another profile to get something that's more relevant to what you're testing. And kind of the inverse of that is you can use incorrect test levels and still pass, but it may not be a good thing. One instant we actually tested and the levels were specified for a US M60 patent tank, which those were fielded, they came out in the early 80s, I believe. And so they cut out all these requirements for an M60. We tested it. The equipment was actually installed in a Merkava, an Israeli Merkava, and failed horribly because the test levels were so different that they weren't really comparable. And so it did pass based on this one test for a M60 tank, but it didn't pass for the other one.
Better.
Okay. Flavor picture on this one, somebody in some kind of New York taxi is going very, very cautiously down the road. Definitely wouldn't actually expect that to happen in the field. Stuff is never treated roughly when you're driving around. DO-160 stuff, pretty much all of this is operational. There's kind of 6 categories. These get divided up and then further subdivided between, you've got a standard random, you've got a robust random, there's some sign. Most of these will also require a pre and post sign sweep as a baseline to show that nothing changed. That's actually really common with spaceflight testing, but not so common with this sort of, kind of military and commercial testing. But one of the requirements for most of DO-165 is to have those sign sweep baselines. Some of the other tests where this differs a little bit is our endurance sign dwells in DO-160 as discrete tests, where those really aren't that extant in MIL standard. It's just kind of a different mode of testing because this is, again, mostly focused on aircraft. You're not really going to commonly see a sign dwell type of situation on ground-based stuff. All the test levels are determined by the installation location in the aircraft, and that is it nacelle mounted, is it wing mounted, is it fuselage mounted, is it in the cockpit, and it kind of splits up more of the tests based on where the stuff is going to be installed. That I know of, there isn't a general cargo profile for DO-160. There is an 810. So if you've just got something that's going to be cargo on an aircraft or not necessarily installed, even if your program calls out DO-160, it may be good to look at some other standards like 810 that do include kind of generalized cargo profiles. Most of the stuff for DO-160 is for things that are installed. There's a lot less tailoring in this. There's a lot less changes. If you get called out, you're going to test curve C. That is most of the time what the program will require, and you can't deviate too much from that. And there's one where for 810, there are some generalized profiles and also mashup profiles where you may be making something that could be installed in a C-130J, a C-5, and say a C-141. In DO-160, you can't do that. You would have to run essentially normally 3 different profiles to replicate that same sort of thing. So again, it's kind of a disparity between the two as far as tailoring goes. One strange thing is that coffee makers on aircraft, so DO-160, a lot of people think it's just major components, okay, we're putting in cockpit components, major stuff, but all the way down to silly things like coffee makers and exit lights still have to go through a lot of the testing that major components do. And these coffee makers are extremely expensive because of that testing, but it is a little interesting compared to what you normally think of what's tested in DO-160. In shock testing, so shock is another one. It's not quite as in-depth as Vibe, but it can be. 3 major types of shock. You've got functional or operational. 810 calls it functional, 160 calls it operational. They're essentially the same thing. There are non-operational tests, and there are also package tests. 810 breaks down into, I believe there are 6 or 7 categories in 810. Functional transportation, fragility, transit drop, and crash hazard. And there's 1 or 2 that it didn't include here because they're not really relevant. Levels are normally determined based on where it's installed. There is a basic ground equipment and aircraft equipment level. For a terminal peak, there's also SRS testing if you know what the equipment is actually going to see in use. The transportation test is one that doesn't get done very often, but it's essentially, if you think of something like a bump test out of the IEC 668 series, it's pretty similar. It's kind of a restrained shock simulating what something would see, in a vehicle going down the road hitting potholes. It is separate from loose cargo. It is an entirely different sort of test. So you shouldn't look at those as being really swappable. They're not. They're different. Fragility is one that also is very uncommon, at least what we normally see in the lab. That is kind of a pre-production prototype test where you're looking more at test to failure to kind of get an idea of, what the equipment can handle, if anything needs to be changed. Um, does it need isolators? Does the equipment just need beefed up? And most of the time that is done at the high and low temperature limits of the equipment. And that is because you're much more likely to fail during a combined temp 5 than you are just regular temp because of the eccentricities of the temperature working on the unit. DO-160 calls out 2 tests, operational and crash safety. Test levels are really low. The basic test level in DO-160 is 6G. In 810, I believe the ground starts at 40G and goes from there. The crash safety test for DO-160 is pretty similar to what 810 does for the impulse. They are both regular shock tests that can be done on the vibe table. Most of the time, you also have to do a sustained acceleration crash safety for DO-160, and that's got to go in a centrifuge. That we'll kind of get into separately for acceleration testing later in, but just kind of some different test types there. Tests can really be done. Most of the time, it's going to be done on a vibe table, depending on the level you have to hit. If you've got to hit, say, a 500G test, you're not doing that on a vibe table. That's more than likely going to be done on a drop tower or a drop tester. The setup for those is a bit different, but the end goal is kind of the same thing. Fixturing and mounting, it's important for vibe, but it's I don't want to say more important for shock, but it almost is, especially for crash safety test, because the intent of those tests is to make sure that nothing flies off and takes off a pilot's head in the event of a emotional event during flight. So the equipment not being mounted, it's pretty common to clamp things down for vibe testing. And that'll show whether the guts of the unit are going to pass, but it just doesn't work for crash safety. We'll get to that again in the acceleration stuff. 2 of the other tests in 810 that we're not really going to go over, pendulum impact or S901 testing, and explosive barge testing. Most of the time, that is limited to shipboard equipment, and they are both very specialized tests that really require very specific equipment. For the pendulum impact, I believe all the test apparatus for that actually has to be signed off by the Navy on a rolling basis. In explosive barge testing, you have to have access to explosives, a barge, and a lake, which most people don't have, at least the explosive part. You could probably get away with a paddle boat and a pond, but don't know if you want to take pictures of that one and put them in your test report. And the poor guy here, so this guy's on the runway, he's driving down the runway, and he hits a pothole in his ejection seat, blows him right out, completely unexpected. But that is kind of what a shock event is you're hitting a pothole and you're falling out of your bloody seat. Thermal shock has nothing to do with shock, even though they both say shock. So there's operational and non-operational for this. It's excellent in both standards. 810 has 4 different procedures, 1A, 1B, 1C, 1D. I don't think it goes to 1E. So there's one way you're basically going from a very low temperature to high temperature, and most of the time, this will be the same limit temperatures as what you're doing during regular testing, whether it's your operational limits or your storage limits. Are going to depend on whether your equipment's operating or not during this test. There are 2-way shocks. So you go cold, hot, cold, or hot, cold, hot. Multi-cycle, where you're just kind of cycling between the two, which is probably the most common. And there is some limited where you're going from a set temperature to just ambient rather than max temp to max temp. In 810, the standard transfer time is just about always 1 minute maximum between the 2 tests. There are some where the ramp to or the ramp from your set point is defined as normally, I believe, less than 3 degrees per minute. And that's just kind of a requirement there. But these are very fast transfers, which can sometimes be an issue when you have very large equipment, or you've got equipment that needs to be operational during tests and it's got a very large cable braid. We'll get into that here in a second after the DO-160 stuff. So in DO-160, all the stuff is based on the location of installation. Not as much information in DO-160 is picking that, but it's pretty simple. All of those are really considered what most people look at as thermal cycling, which is a temperature change rate of less than 10 C a minute. That doesn't really constitute a temperature shock test because that is something that's seen in the real world. Most of these are controlled rate thermal change rather than direct shock like MIL standard. So you have controlled ramps to and from rather than in and out really quickly. Again, that kind of goes back to most of your equipment for DO-160 is going to be installed, and you're not going to be seeing those major changes like you would for DO or for 810, where you may have the Pelican cases coming out of a uncontrolled cargo space in the C5 that was, just zooming around, and it's extremely cold, and it lands in Dubai where it's extremely warm. Most of the stuff for DO-160, what the plane is seeing internally is going to be less than that. The cycling for this can be integrated into the overall DO-160 temperature test procedure, which is a very kind of step-by-step kind of thing. It does include some information on how to do this, but it may be better to kind of plan on this being a separate test because as a temperature strafe test, this one's the one that's probably going to cause stuff to fail more than anything else. So if you can isolate that from your regular temperature testing, it allows you to kind of split up failure modes between the two. Down here, we're going to do where the EET size and configuration, it may be tested in a single chamber or a dual chamber. Dual chamber is pretty common when the equipment is large or you've only got, say, 1 or 2 shocks. Single chamber, what they call an elevator chamber, is common for smaller stuff or for things to have a lot of cycles. So if instead of just doing 6 cycles, you're doing 600, most of the time it's probably going to be done in an elevator chamber because those can be programmed to cycle automatically rather than manually moving things around. One of the limitations of those is that those chambers are typically smaller, and at least I know most of the time limit the equipment being non-operational just because of the design of the chambers. I don't know how, but somebody got a picture of me about to do a polar bear plunge. I got to go find out what's going on with that. Not sure. Altitude. So we're going to start because space plane. The SR-71 is, I would say arguably, but it's not. It is inarguably the coolest plane that's ever been made. Just flat out. That's it. That's it. And it goes very high. So I think SR-71 pilots are actually rated as astronauts, probably along with the spy plane guys. But yeah, space plane because it's cool. So for altitude, kind of again the standard. You got an operational, a non-operational, and a rapid decompression. Non-operational is mostly going to be for cargo, although it can be used sometimes for equipment that will be installed but not active during testing. Rapid decompression is for stuff that is going to be in a pressurized cargo compartment and may see a rapid decompression if something happens, like if you're on a C5 and you get hit by a missile, which would probably be a very bad thing for everyone involved. But that's where that kind of test comes from. 810, you get some really basic stuff. They basically say stick in an altitude chamber and do a test. So most of the time, these levels and durations either get determined by the procurement agency that is driving the testing, the project requirements, or what people actually know it's going to be used in. So if it's going to go in a 757, you know what the maximum ceiling height is for that. DO-160 is more specific. These categories for altitude are actually part of the temperature category selection, so they're kind of locked together there. And most of this is going to be determined by where the equipment is installed on the aircraft and the maximum operational ceiling of that aircraft. Again, this is a lot less for cargo and more for equipment installed in the aircraft that's needed for use. Normally, this is going to be the least impactful test in the entire suite. In 16 years, I've only ever seen 2 things that failed altitude testing. And one of those was operational at 70,000 feet, which is normally not a good thing when you're relying on convective cooling and you kind of run out of atmosphere at 70,000 feet. One thing, if you are doing operational tests, you might have to modify your cables to make this test work, depending on the cable pass-through or bulkhead that the chamber has. Even something like an Ethernet cable, if it's a loose sheath, can have enough altitude pass-through from the outside of the chamber to inside to prevent a chamber from being able to hit target pressure. It really, once you start getting at a higher altitude, it takes very, very little air to prevent you from being able to go any higher. DO-160 has a weird overpressure test where you go to the equivalent of negative 15,000 feet. The standard says this is for when routine cabin pressure checks are performed, but it seems slightly excessive at that level to me, but that is the requirement. So 810 doesn't have that requirement. Um, it is strictly an overpressure for DO-160. Sand and dust. This is one that may not ostensibly really seem like it would apply to aircraft stuff, but it does, because a lot of times when things are landing in the desert, especially rotary aircraft, there is a lot of sand and dust kicked up. There are, ignoring what happens when, sandstorms hit when equipment's on the tarmac, it's not always the best conditions when you're loading and unloading equipment in the field. So sand and dust, maybe even in a limited application, useful for a program. Operational, non-operational, a lot of that really winds up being dependent on what the equipment is and what it's doing. The requirements of the standards are almost identical. The sand concentration, test temperature, and wind speed are really the big variables. So DO-160 is a significantly lower impact test than 810 in this regard, because again, it's assuming that most of the stuff is either inside the aircraft or external, where it's not going to see really sustained severe sand and dust bombardment. 810 includes stuff that is going to be on the ground, so it might be in a FOB in Afghanistan where they're going to see a lot of, blowing sand and dust around it, and it might be there for 2 years. So it may have a very, extended service life where the effects of sand and dust are going to have a lot more kind of impact on that. So the levels, the dust levels, the sand levels, and the wind speed especially is significantly higher in 810 than DO-160. This one probably is going to make your stuff look like crap. Kind of when you abrade something with sand for a couple hours, it normally does that. Not quite as bad as sanding it, but it is pretty bad. One of the things where this can actually come to effect is for equipment with screens. One of the requirements may be that after testing, the screen has to be usable. And there have definitely been some of the tests we've seen where afterwards the screen just looks like a frosted white sheet. So that's one of the things to take into account, is that, after sand and dust, you may want to not use that EUT for other testing, especially if you have to put it on a vibe table and all the sand that's stuck in the unit comes out while it's on the vibe table. That never results in a very unhappy test technician. One of the other things you want to kind of think about with sand and dust is how it's going to actually be deployed. If it's going to be something that's going to be man-packed, if it's going to be something that is in a sustainment pouch or a backpack or covered up or something like that, it may be better to test it that way. Again, that's kind of a procurement or a project requirement, but it's worth thinking about, where if you're going to have something that is almost always in a pouch, subjecting it to a test where it is completely exposed may not be especially realistic. If the equipment fails, it may not be a true test failure. So you kind of have to think about that a little bit. Over here, you've got a guy who's very happy in the front. He and his buddy are out doing some outdoor adventures, or just zooming around. All kinds of dust, and I'm sure it tastes great. That's the best part about dust. Salt fog, again, kind of like sand and dust, is one that doesn't really seem like it would affect a lot of equipment, but for anything that's going to be on a carrier and a naval base, for anything that may be stationed in Florida, this is one of those tests that it probably is not a bad thing to do. So almost all these, the standard is non-operational. You can operate your equipment if you want to during tests, but you really need to consider things like electrical safety for that. When equipment fails electrically during a salt fog test, things get very spicy. Salt fog, again, like sand and dust, the test requirements of both standards are almost identical in this case. 810's got a basic test where it's 24 hours in the chamber, 24 hours out of the chamber, so a wet and dry cycle. And the nominal is 24 cycles, so 4 days total test. That can be extended out. The earlier versions of A10 actually used a single 48-48, so 48 hours wet, 48 hours dry, test ends unless you extend it. DO-160 is the exact same thing, except they have a severe category where it does extend that wet cycle to 48-hour duration. Even though that is more severe, one of the things they noted in MIL standard, one of the reasons they changed is that after a lot of data crunching, they found out that doing more shorter cycles, especially the drying cycle, because that's where a lot of oxidation occurs, is more realistic and more severe than just a straight 48-hour test, or something like ASTM B117, where the equipment may go in for 30 days but never actually have a drying period. So even though some of these other tests may have a longer wet cycle, they may not be as severe as 810 when it comes to that sort of thing. So it's one of those things where might not really be applicable to the program, but it's something to think about if stuff may be deployed where there is salt, which is a relatively large chunk of the earth. But yeah, somebody's poor Degtrev. I don't know that CLP is going to fix that guy. Somebody's got a YouTube channel where they could probably do it, but in terms of post World War I Soviet machine guns, I think that guy is done, unfortunately. And that is what salt fog does. Incidentally, if you have a PCB that you want to test and it is not conformally coated or potted, and you do a salt fog test, the only thing you're going to get out of the chamber at the end of the day is a bare PCB. Bare components like resistors and capacitors and ICs and that sort of thing do not fare well. Even though everybody thinks they'll do fine, they don't. So you really want to do a salt fog test on something that is enclosed and is going to protect the sensitive guts from salt. Explosive atmosphere. So this is one that is moderately relevant. I don't know that I've ever known anything that failed this test. It is mandatory that the equipment operates. Test requirements, again, are pretty much the exact same, except that MIL standard has an altitude requirement, typically done at the maximum altitude that's rated for the equipment. DO-160, everything is just performed at ambient pressure. And the intent of this test is you basically take a chamber, fill it with stuff that explodes, put the unit in it, and see if it makes stuff explode. You have a very explosive mixture of hexane and I don't recall offhand what the other material, what the other chemicals are, but you actually do some pre-test where you ensure that the mixture in the chamber detonates before you put the equipment in. And this is one of those where there's really no way to do a non-operational test. The entire point is to show that there isn't a spark hazard with your equipment during testing. So you kind of have to operate it. If you got something that's non-operational, there probably isn't any reason to do this test. Two big procedures, two big methods. Explosive containment, where what you make is designed to contain an explosive inside it. Relatively uncommon, I would think. The other one, which is more common, is where the EUT operates without causing explosion. So somebody on the tarmac has actually just knocked over a 55-gallon drum of Jet A, and while your equipment's operating next to it, it doesn't create a spark that's going to blow things up and make some people very unhappy. DO-160 has another method where it's looking at surface and component temperatures rather than operational rather than the operation of the unit causing a spark or something that would cause a detonation. DO-160 has one where you're looking to make sure that the surface temperature or an individual component temperature doesn't get to the point where you have flash ignition internally to the chamber. Again, operational testing is required. When I do the Google search, I don't know who this guy is, probably definitely not from a movie called Die Hard. But cool guys never look at explosions. You just don't do it. So even if you're in a plane and it blows up, you've got to look the other way. It's just kind of one of those, guy rule requirements. Acceleration. This one is relatively important for a lot of flight equipment. You've got operational tests, structural, which are normally subdivided into limit and ultimate load tests, and crash safety, which links back to some of the shock testing. So the test requirements, again, are pretty similar between these two, between 810 and DO-160. 810 will most of the time call out actual loads or calculated loads based on the aircraft and installation location. So there are some extremely complex formulas for determining that sort of thing. the math is too hard for me to figure out, so I let people smarter than me do it, and I just test it. But that's one of the things in 810. They do have some basic levels, but the intent for this in 810 is really to know where your equipment's going to be installed so you can have reasonable and realistic test levels. DO-160 lists set levels, but they actually do make a note in this one saying that while these limits are set in the standard, they may not meet the requirements of the procurement or project, and they may need to be adjusted as such. It's about all DO-160 says about that, I think, in terms of tailoring, but it is there. It is something to think about. Limits in DO-160 aren't especially high. They aren't especially low. They're just kind of there. One that really, one that I have never seen called out in 810 as a sign burst or quasi-static test, where anybody who's familiar with spaceflight testing, quasi-static is essentially a static load test. 810, rather surprisingly, does include it. I don't know why. I've never seen it called out, and all I can think of is it's for some very esoteric, expensive stuff that probably goes to very specialized labs, but it is included. With sign burst, there are a lot of contingencies on creating the profile. The test frequency needs to be 1/3 of the first mode in relatively whole numbers, other things like that. Since it's not especially relevant to what most people are going to see, not going to spend any more time on that guy, but it is there. It's essentially a very high level, very short, say 2 to 10 cycles sign sweep or sign dwell, just at very high levels. If you are doing acceleration testing, the central use design can limit how many channels your unit may have. There's only so many slip ring channels, so you may have to limit operation if you are required to operate during testing. Not especially common, but sometimes that is called out, so it's one thing to think about. And again, fixturing for acceleration, like with shock, it needs to be as similar as possible to where things are going to be installed. If you're installing things in a rack, you really need to figure out a way to do a simulated rack mount to test the equipment. If you just clamp it down for testing, most of the time that's not going to be acceptable because you're not stressing the mounting of the equipment, which is really what this test is looking at doing. Making sure that stuff doesn't come loose, that it survives an acceleration test, and still works. But the biggest part of this is making sure stuff doesn't come loose and move. This guy, if you've never seen an F-22 in person, they are slightly impressive, I will say. Just a little acrobatic, and he is actually in this picture going from runway to VTOL just like that, and they can actually do it. They are amazing to see. Next to the SR-71, probably one of the coolest aircraft we have flying around right now. But that is a really good indicator of where you may have a very high acceleration. And my thing shouldn't fly out of bomb bays and that sort of thing. Fluid susceptibility is another one of those, kind of like salt fog. This is mostly limited to where things are going to be exposed to chemicals. So you're going to see things like hydraulic fluid, jet fuel, de-icer fluid, all that sort of things. Both standards do have lists of chemicals to use. The 810 does actually get into military part numbers and stuff like that to really nail down on the exact stuff. 810 is what they call occasional, intermittent, extended. DO-160 has spray and immersion. The intermittent and spray testing are nominally the same, and the extended and immersion testing are nominally the same between the two standards. The occasional was for stuff that isn't expected to see fluids, but somebody may accidentally drop coffee on top of it, and you got to make sure it'll survive that. Most of the time, the equipment temperature is going to be at lab ambient. Fluid temperatures will normally be what they would be in use. So if you're doing a hydraulic fluid test, you're not going to do it at room temperature. You're going to do it at an elevated temperature. One of the things to watch out with that is a lot of these fluids can be extremely caustic, corrosive, dangerous to be around. So you really need to make sure that that's kind of taken into account when you're doing this test. And you can see up here kind of one of the things that commonly happens with fluid susceptibility is most stuff's metal. It's really not going to affect you. You may have some surface icks where, the paint may come off a bit, but for stuff like this, where this is, a rubber overcoat or rubber buttons or stuff like that, hydraulic fluid is really, really bad at turning that stuff really sticky and really goopy. And that can cause stuff like soft touch buttons to be completely inoperable. So if somebody accidentally knocks over a hydraulic oil can on top of your equipment and it's got soft touch buttons, that's what may happen. And that's kind of what this standard is looking at, or this test is looking at. Some of the fluids that are called out, JP8, STB, supertropical bleach, can be hard to extremely hard to get. Most of the time, if you call an airport asking for JP8, they tend to get very alarmed why somebody who doesn't own a plane wants jet fuel. So there are some times where, in a program, you may need to get the procurement body, whether that's the Navy, the Air Force, whoever, to either provide an alternative or actually provide that fluid. Supertropical bleach is just some nasty stuff. I think it is technically out of circulation for use now, but it is sometimes called out. This test often results in an EUT unsuitable for other tests. Yes, when your unit is done, this is going to be gross. It's going to be disgusting. You're probably just going to want to throw it in the dumpster unless it's got really expensive guts in it or the government already owns it. So one thing you want to think about with this is if you do have to go through fluid susceptibility testing, either dedicating a unit just for that, or once that testing is finished, that unit isn't used for further testing. Slight caveat on that is some requirements will call it a decontamination test afterwards. Sometimes the decontamination fluid is actually part of the fluid susceptibility test. Sometimes that decontaminant fluid is a separate test. But the intent with that is to show that the equipment can be cleaned off afterwards using field common solvents that are actually going to be used to restore the unit back to some modicum of functionality. That may be something that the program or the procurement requirement doesn't call out to ask about. That way you get a unit back clean because the lab had to clean it for you. Some other projects, and this is one we actually did, we had to use simulated blood. So it's not always Jet A and hydraulic fuel or hydraulic fluid and that sort of thing. Sometimes there are biological contaminants, depending on what you're testing. So it's something to think about. And that's kind of the end of, we're at the time limit anyway, but that's kind of the end of the most applicable tests for this type of equipment for these two standards. There are some other standards that get called out pretty often. MIL Standard 202 is older, I believe, although I may be wrong, than 810, but the intent for that is to test just components or component level assemblies, and the test levels are also significantly higher in most cases than 810. So you may have a 5,000 G shock test as an example in 202. Which requires some very specialized equipment and very specialized components to survive that sort of test. But some methods of 202 will be called out in a multi-standard program because some of them are relatively analogous to 810. 167 is shipboard specific. Normally, this test is a 4 to 33 hertz vibe test for equipment mounted in ships. Now, that bandwidth can change depending on if it's going in a known ship like an LCS. During the LCS program, they had a modified version of 167. Not really going to be relevant to most of the stuff here, although it is occasionally called out if stuff may be installed on a ship and in an aircraft or multi locations. That test takes about 3 days. Probably not going to see anything fail, but it is something that the duration gets some people sometimes. The IEC 668-2-XX, so this starts at 1 and goes up to, as far as I know right now, 78. And this is kind of a commercial version of 810 where each test is its own substandard. So 668-2-36 may be sign sweep, 37 may be random, 38 may be sign on random. So it divides that up and gives generally hard requirements for test levels and durations in those standards that the PM or the procurement officer, whoever, needs to decide on before they call out that standard. Not very often used for strictly military stuff, but for a company that's making ruggedized equipment that they may want to springboard into COTS to get into the military at some point. A lot of times that'll be the starting point for things, just to see how they go. ASTM, I'm not even going to attempt to list all the ASTM standards here because they are insane. And if you find one ASTM standard that you have to test, you're probably going to have to buy 6 other ones just to find out what that original standard wants you to do. But it is relatively similar to the IEC in that each ASTM standard generally breaks the test down into different things, different tests. Inside those standards, they will tell you to go look at a different ASTM standard for the procedure, another ASTM standard for the levels, and another ASTM standard for the duration. They are not especially popular because of that, but a lot of times they are required. So that's where the ASTM stuff is. NASA GEVs, probably not going to be applicable for most stuff, but like 810, there is an insane amount of technical information when it comes to things like vibration testing, quasi-static, shock testing, selecting levels, selecting loads, all that good stuff. So if you're ever very bored, or if you have an intern who you need to fob off and do something after they brought you the coffee in the morning so they don't bug you, tell them to go read GEPS, because there's a lot of stuff there that honestly will be really useful. It may not be directly applicable to a program, but there's a lot of information in there that can really help people out. Okay, questions?
All right, since there weren't any questions online, I'll extend this time to say if you have any questions about this webinar, or you think of some after the webinar, go ahead and send your question to questions@wll.com and we'll respond to you as soon as possible. Our next webinar will cover space applications for EMC and ENV at 1 p.m. on October the 10th. Be sure to visit our website and sign up to receive email notifications for all of our upcoming webinars. You visit WLL.com and you click on upcoming events. So on behalf of Washington Labs Academy, I'd like to thank everybody for their attendance. Our thanks go to Corey for taking time out to enlighten us about MIL Standard 810 and DO-160 for military and aerospace. And with that, I'm going to go ahead and end the event. I hope everyone has a great day and see you next time. Thanks.